Hello, in this video, I want to show you how to project or map a kind of geometric pattern onto a curved surface like a dome or vault. So at the end of this tutorial, you will see how you can create such a kind of geometrical pattern on a dome. The pattern that we want to parametrically model today is this basic module that you can see here. And as you can see, this pattern is actually a kind of like a rotational replication of, again, another single module, which is what is bounded in this rectangle. So we have like two lines. One is this line, and the other one is, I think, well, the mirror one, the mirror part of it. So one is this one is the other one, and also these two are mirrored along the diagonal of this square shape form. So we want to see how to create that. Let me first turn off all of these components. Okay, and also this one, and start from the very beginning. Okay, so first of all, we want to create a rectangle. For creating a rectangle, we should define the plane, and then setting two sliders. Actually, since here I want to create like a square, I can create just one slider and connect it to two input parameters of X and Y lengths. I will click on that, turn it into like floating number with 1 decimal place value here. And you can see this tiny little square here, which I'm going to maximize it here to 10. Okay, that's fine. Now, the next step is that we want to find the vertices of this square to be able to draw a line along the diagonal and use it as a rotational axis. To do that, we should decompose this rectangle. So by exploding the rectangle, I can get the vertices. Okay. And I can use list item to indicate which vertex I want to work on. So I will work on vertex index 0 and 2. And here are. Okay, so these two items show the 2 points that let me define the 2 ends of that. Also, I'll keep these 2 vertices and show you later what I want to do. And then another items I need to define is that if I just turn this on, I can show you what I want. So I want 2 lines be defined, and these 2 lines, I mean, which are actually a reflection of each other. You see that the 2 end vertices of each line is placed on these edges on the of the square. So we need to define 2 points on these 2 lines to define a line. In order to do that, when I exploded the rectangle, again, I should use list item. And here I get the segments, like the edges. To define on which lines I'm gonna work. So this is this line and this is the other line, okay? Now I want to define a point on each of these two lines. So I would say point on curve. I look for a component call, which is called point on curve. And I will give that curve to it. So you see here, there is a point that you can like play around with its position through this slider. I make another one and connect the other edge to it and create 2 points. Now I want to draw a line, simple line, connecting these 2 points together. So now I have this line. In order to create the other line, I mean, actually to mirror that, we need to mirror the curve or an object. To mirror any object, we need to define a mirror plane. To define the plane, we should actually use the plane. Well, there are different ways to define that plane. I mean, by default, the mirror here is the YZ plane. I can use YZ plane and place the center point of this plane at the midpoint of this diagonal. First, let me draw the diagonal line of that square. Here we go. And now I want the midpoint, a curve middle. Here it is. So it gives me the middle point of the diagonal. And I can place that plane here at the center point. So see here. Okay. Now what I should do is to rotate that plane. If I show you this plane in the top view, it is this, and I should rotate it for 45 degrees. So I can do that. Rotate this geometry. And what is the rotational plane? That is XY plane. And again, I move that XY plane here. And what is the rotational angle? I'll set it to 1/4 of pi. Okay, there we go. So let me turn off all of these. Oh, actually, I should rotate it for negative 45 degrees. So now the plane is aligned with this diagonal. Now I have my rotational mirror plane, and I will connect it to this mirror component, and then I will get these 2 curves. Let me just turn this off as well. So now I have 2 lines here. I need to also have another line. I'll turn this on. To show it works. So we already defined these two lines, and we need to also define these two lines as well. As you see, these two lines are laid on XY plane such that one vertex is positioned on the diagonal, one vertex is connected to like the vertex of that square shape. So I turn this diagonal on and also this line on. Again, I define a point on curve, a point on curve by connecting this diagonal to this slider. So one end of that line, one vertex of that line will be placed on this diagonal. Just move this up, okay. And the other one will be positioned here at this vertex. So again, now I call for index 1 and index 3. So you can see this vertex and the other vertex. Okay, now I have this line. I have these points, and I want to draw lines. So one should connect to this vertex and this point, and the other should connect to this vertex and this point. I could also draw just one of these and mirror that. So for example, I could just connect this line to this mirror component and have all the lines that I need. I'm just going to turn off that diagonal member. Now I have my module. The next step is to use polar array and connect the geometry. Sometimes it's a good practice to just call for a curve component and connect all the lines we want to use as an input value to a single component curve. Now, when I click on curve, you can see all the 4 lines. So I connect the curve to the geometry. I define an XY plane. I turn this off. There we go. And the number of replications, rotational replications, which is 4. And here we are. This is the module that we created. Now, if we play with the position of these points, we can create different shapes. The next step is to replicate this module along the X and Y axis. So I call for a rectangular array. So again, this is the geometry. What is that? The rectangular array cell. So we can use bounding box component here and right click on that and say the union box. So you see that, oh, we should connect actually this. So we can get the bounding box of this module, and we're going to replicate that. So here in the rectangular array, we can actually use this box as well. Okay, and give the X and Y, which is the number of replications. X and Y axis. Okay. Now let's see. Here we are. So here is the pattern that we can create. Let me just reduce these numbers. So here is the first step where we created a flat a flat pattern of these geometrical forms. The next step is to project or map these patterns onto a surface. In the previous videos, we talked about how to create a dome, a spherical dome surface, or a barrel wall surface using the revolving component to create a surface. You can review those videos that we talked about that also in the class, and I discussed the creation of these kind of surfaces in details in the prior videos. Now I take that dome surface here, and I want to map this pattern onto this surface. What I'm going to do is create I'm going to use the surface morph component. So this is the geometry. I go with 7 by 7. I connect that. And here it asks for the reference box to map from. So again, I can call for bounding box here, connect this geometry. Well, you see, there will be like multiple bounding box, but I right click on that and use union box. So then I will have just one single box here. Okay. And then I have this target surface, and I should say what is the U and V division. So I will say, I will call for deconstruct domain. So I need to deconstruct the domain of this surface in two directions, get the divisions along the U and V directions. So I will just connect U to this component and V to this component. And here will be my reference box. And here it says surface space. We should define the W extent. So I will just go with 0 to 1. Floating number with 1 decimal place. I will put it here. Of course, it can't be 0. Here I will get an error. It says the reference space volume cannot be 0 because the bounding box is actually here flat. And that's because we arrayed a 2-dimensional pattern. So what I'm going to do is I'm going to extrude this geometry and give it also a depth. There we go. And then I connect this extrude to my bounding box. Now let me turn off here. You see, again, the patterns are not properly mapped, so I should Now, flatten the outputs here. And now you can see those patterns. Let me just, I mean, it seems everything is too crowded here. So I'm gonna just a little bit reduce this shape. Now you can see how nicely these patterns are mapped. One other thing that I should control, it seems a little bit like the patterns are a little bit funky here, is that also I should flatten the input of this bounding box here. So then we should be all set. I can minimize the thickness, and also I can play with the number of elements. Now you can see, of course, this one would be a little bit crowded. And also here I can play around with these vertices, points, and play around with these geometries. Here we go. This is how we can get a dome with these kind of geometrical patterns.